Greater estimates than the IPCC Tier 1 data, which has looked at agricultural land just from the standpoint of soils. But when you look at the biomass on that land, you come up with a whole different picture. Now, if we look at the change in carbon on agricultural lands, we look at a picture where South America and Southeast Asia, the blue areas, have ranked highest in total above ground biomass carbon on agricultural land. And they had the greatest increase in biomass carbon as well. In those regions, those blue regions there, the increase in biomass carbon over the decade was about 7%. During the decade, there was also an increase of greater than 2 picograms of biomass carbon on agricultural land globally, or a 4.7% increase in biomass carbon. Now let's face it, this is really good news, because agricultural land overall is actually gaining in carbon at a significant rate, and these gains can be further accelerated. South Asia and Australasia, primarily Australia, have both exhibited significant increases in biomass carbon on agricultural land. In those areas, it's been about 8% increase, which tallies with, for example, India's data on increased tree cover that has been published recently. Brazil has the greatest amount of biomass carbon per hectare in the world. And it also has almost 14% increase in biomass carbon between 2000 and 2010. Indonesia's biomass carbon, you see the dark purple there indicating high rates of increase in biomass carbon, is about 9% increase over the past decade. Biomass carbon on agricultural land in both China and India has increased about 7% during the decade as well. So what are some of the implications of Bob's analysis? There is 9 times greater total carbon stocks on agricultural land than is currently assessed by the IPCC estimates. There was an additional increase of 2% tree cover in agriculture between 2000 and 2010. This caused an increase of more than 2 picograms, or a 4.6% increase in biomass carbon, which translates into something like 200 million tons of carbon sequestered, stored in the landscape annually. The pervasive contribution of trees in agriculture to the global carbon balance, however, is still almost entirely ignored. And this, we hope, will not continue. Now we balance these kind of positive trends with the alarming trend in biomass degradation in large parts of Africa. The red on this slide shows a long-term trend of negative biomass on agricultural land in Africa. But you know, those trends are part of that overall global average. And if we can reverse the trends in negative biomass that we see in Africa and some other parts of the world, we can make a huge increase in our overall rate of biomass carbon. And that is part of what the new Africa 100, the African initiative to restore 100 million hectares of land, is all about. And when that program was released or launched in December at the convention, we found that we're looking at combining 3 major systems of land use for increased carbon storage on the landscape. Forests, croplands, where you have the Vision 2025 or 2525 for climate smart agriculture, and pasture lands. Pasture lands actually, in our estimates, dominate the potential for total area of restored land in the coming decades. The good news is that political commitment to scale up restoration successes is growing. And 17 countries have now made commitments since December, including Ethiopia, Kenya,